education and did such a fabulous job that I had to fire her and hire her as a faculty member. So that has worked very well. Dr. Christelle Scharf in the back, who is the chair of our and is the absolute epitome of bringing creativity into technology. So I've talked more than enough. I am so grateful to you all for being here, and enjoy the show.
And before we forget, I also want to just give a round of applause to one of our other faculty partners. I teach PDP and PIP with Drew Gandhi. Before we start, I just want to quickly explain what PDP and PIP is, and Andrea is going to explain what CBI A3 is. Product Development Project, also known as PDP, is a course done at Aalto Design Factory, part of Aalto University in Helsinki, Finland. And this course is run in conjunction with design factories all around the world, part of the global network. Some of the universities include Warsaw Polytechnic, Porto Polytechnic, Yonsei University in Korea. Product Innovation Product is run in conjunction with Technical University of Graz. It's their course, and we serve as one of their international partners. Both courses are very similar in that we partner with industry partners. They give us a challenge that they're trying to solve, and they also give us funding. And it's our job of our students, as they work in international, interdisciplinary teams, to try to figure out a product or a service that addresses that challenge. And over the course of about 8 to 9 months, they use the process of design thinking, all 5 stages, and they meet with the companies for company meetings. We had one just this morning. And they present in May or June their final product to all of the industry partners, not just theirs. And we're very fortunate enough that many of our projects have gone to market and have been patented, which is amazing. Yeah. It's very amazing to be a 21 or 22-year-old and have your name on a patent, or be able to look on the website and be like, I helped make that product. And we're very excited about that. And I'll have Andrea kind of talk about CBI A3.
Thank you, Jackie. We have some new folks here, so I would like to introduce what Design Factory is all about, in case you've never heard about the Design Factory. And it's basically a platform for experimentation and co-creation, where our students are introduced to problem-solving based learning. And we have a variety of activities and courses that are under the Design Factory umbrella, working in a fashion described by Chaplin. And one of those projects, and a new project to our portfolio, is the Challenge-Based Innovation Project. And the host of our experience is none other than CERN, the European Organization for Nuclear Research. Many of you might know that it's one of the largest nuclear physics, particle physics research facility in the world. You may also know the place as the home of the Large Hadron Collider, and also the place where the God particle, or the Higgs boson, was discovered. So it is a great pleasure for us at this university and our students to have the opportunity to work with CERNies, as we affectionately call researchers and folks at CERN, to devise our solution. One interesting fact about the challenge-based innovation is that it's looking at connecting CERN technologies, applying those with United Nations Sustainable Development Goals in an effort to devise solutions for the future. So while in PDP and PIP you are, in a way, developing solutions for the now, the CBI project is looking at the year 2030, for example. And as part of the CBI, we have a few other partners. We work with the Swinburne Technical University, with the Porto Technical University, and University of Mannheim. And the rest of the project will be described by my
Jackie. First up for the presentations, we have Team Logic Data. That's a big thing.
Good morning, everybody. We're Team Logic Data. So to start off, we'll introduce ourselves. So my name is Noelle Howard. I'm a student at Pace University, and I study economics.
My name is Ahmad Shirchich. I'm studying computer science, a master's program at University of Technology in Graz.
My name is Azana Chaman. I study here at Pace Information Systems. And that's it.
Hi, I'm Sammy Champley. I study computer science here at Pace.
Hello, I'm Valentine. I'm a study electronics engineering.
Hello, I'm Ahmed. I'm studying production science and management at UCAS.
And my name is Medina Zeka. I study business administration at Southampton University of Health.
So they will join us back up later for questions at the end of the presentation. Thank you, guys. So to start off, like Jackie mentioned, we partner with industry leaders and companies over in Austria. So our company sponsor is Logic Data. They're an electronic and software development company, so they create mechatronic adjustable solutions for home and office furniture. So they're more established in the office sector right now with the desks that are height adjustable, but they're transitioning into the home sector with adjustable beds as well. So Logic Data provides us our challenge. So this year we will be identifying target groups, keeping our consumers' needs in mind as we ideate and design and automatically transforming furniture, specifically for the home, and more specifically looking at micro living spaces to maximize your space usage. And we'll also be forming a business case based on the market that the company will be entering. So to start off, we began researching some global trends to get an idea of what forces were at work in the market to better our understanding. So in a big overview, in the US and Europe, there's a huge trend towards urbanization. So you have a lot of people moving towards the cities. And in the US, it's forecasted to grow to 87% by 2050, and in Europe, over 60% by 2030. So for housing trends, this means that in 2016, 36% were actually renting their homes. So you also see that trend towards renting, and this can be very popular, as we know, in urban cities. A lot of us in New York rent apartments very commonly, and that ties into our age range as well. So we'll be looking at young adults because they are most likely of all age groups to be the people renting houses and renting homes. So to better understand our consumers specifically, we did interviews with students that lived in dorms in the US as well as in Austria. So we conducted 14 interviews, and our key takeaways when we asked them about their space and their dorming situation, their biggest complaint was that they didn't have enough space. There was a big lack of it. So that's something to keep in mind. And also, when we asked them about the furniture that they use most, many cited their bed as being kind of multifunctional. They use it for work, they use it for studying, for relaxing. And that was something to keep in mind and kind of a base for our ideation. They also, as we all have probably recognized, electronics play a large part in our work, in our relaxation time, and so that is also very prevalent in the age group that we're looking at in their everyday life, how they like to use their space. Many didn't have automated furniture, but they cited they would be interested in it. However, they would be concerned about cost and if it was manually adjusted. So taking that all into consideration, we ideated, and Afan will be presenting what some of our top ideas were.
So we can show you how it should.
So this is actually a prototype for one of our other ideas. We thought it might work best to kind of show you since it can be hard to wrap your brain around.
So here we have a bed which is height adjustable with support rails which are attached to the wall, and when it's height, so it's in the air, so we can form a couch or a bed with these extensible rails. And here inside we have a table which can go out and in, so it's extendable. And which can go up and down the domain, it's height adjustable. And this is not our final idea, so we have some further steps we have to do. They will include an evaluation of our ideas, so we can find out which are the best ideas we have. They will run some metrics. We have to build a functional prototype, and of course we have to test it with our potential customers. We have to develop a present business plan for our company, and of course we have to present our final project to Logic Data.
So we just want to say thank you so much for coming and listening to our presentation and giving us your attention. And we want to encourage you to live smart and expand your space. So now, correct, we'll be going into questions. So are there any questions in the audience? Maybe about some specific things, the project in general?
If you were asked off the cuff to develop a product, you probably wouldn't develop it. What's important to learn if you're actually going to be asked to develop a bid and spend time researching? What do you need to know?
One of the main things that we learned when talking to students was that, especially when you look at the dorm case, is the bed is used for many activities. So in my opinion, I would definitely say understanding what the consumer wants to get out of it, whether they want to have it as a space to do their work, or whether they want it to be used for relaxation. So keeping that in mind helps drive our ideation of what type of different softwares or what type of different features to include on it to kind of cater to those needs.
What kind of material is it going to be? Because I'm concerned about the cost.
Well, if you're considering cost, why not carbon fiber? It's the cheapest material around, right? No, honestly, I would use wood because it's the base material. It's very cheap. Yeah, weight might be a problem, but we're not done ideating and we got a lot of full concept.
It has to be light as well, right? And safe, so it's safe to use.
The company does have some already created
Oh,
electronic pieces if you want to explain it.
so Logic Data has something already in their series. It's called the Silver Series, which is basically an adjustable bed frame. And it can hold up to 700 pounds, but what they really market is that the fact that it all fits in one box. And you get shipped a whole bed frame in one box. Sorry. So,
No worries. Yeah, so they definitely are trying to kind of promote the not to be as scared of these like automated pieces and that, you know, it's very easy to bring it into your home and kind of downsizing the shipping size when you get it and be able to fit together. So
it also takes 10 minutes for the user. So no professional has to put it together. So it takes 10 to 15 minutes to put it together yourself.
How do you control the up and down motion? Is it software or you?
Yes, it's run through software. You just have to press a button for up and down, and everything is done by software.
Have you thought about, if someone asks you the question, how do you hack that? Someone sitting in their bed and someone like me hacks into it.
that'll definitely be something to think about in the future.
Voice recognition, very good.
Yeah,
If you're talking dorms, your user is a student, but your customer is actually a university.
Yes.
How do you manage the two different customer models there?
That's something that was very interesting, and we quickly realized we were able to actually, fortunately, do an interview with our Dean of Housing on campus here at PACE. So we were able to kind of get the university's insight as to what they look for in the products, and we did realize that dual kind of customer you're catering to because your end user isn't your purchaser. So it definitely, in my key takeaways, the university very much so does want to listen to the students, but at the same time you have to think about longevity of the furniture and cost. And another thing that I thought was really interesting, which I hadn't thought of until we interviewed with them, was the kind of like replacement time. So a really big thing for them was how quickly can we get new pieces if something breaks, or can we get it replaced and repaired. So that was a factor that was very kind of prevalent in their decision making of the companies to work with as well. I don't know if anyone else wants to add.
And is it named for Valentine?
We'll never know.
Any other questions?
Price point? Have you put any numbers on this yet?
Not yet, no. Okay, thank you.
Thank you, Logic Living, for sharing your product ideas. Next up, we have Team Rapala.
So, hey everyone, I'm Sammy.
I'm Niaz.
And we're from Team Ruffalo. So this is the rest of our team. On the top here, we have students from Finland studying at Aalto University. Down here, we have students from Poland studying at the Warsaw University of Technology. Of course, awesome place. So the company that's sponsoring us is Rapala. They're an international fish supply company, one of the world's biggest. The biggest market share is here in the U.S. They make lures, rods, fishing line, knives, clothing, any kind of accessories for fishing. Over there, you guys can show you some lures that they made.
So, fun fact, during testing, we stabbed ourselves in these
So from they presented us with was designing a next generation digital fishing lure.
And so what you thought was the variation. How do we get fish to come to our lure? So what factors affect our fishing experience? Well, there are a plethora of factors that affect it, ranging from lure color, lure weight, weather, species of fish, and so on and so forth. And our team decided to work with color. We thought color because it's the most malleable factor and the one that we thought we could control the most. And fortunately, our consumers also thought so. Over 1,100 surveyed fishermen, multiple phone interviews and face-to-face interviews, and about 68% of all the people that we interviewed said that color was their most important factor in the lure. So we decided to move forward with color.
So after our ideation, our next phase was prototyping. First thing we tested was electroluminescent materials. So you can see here, when given a voltage, the materials light up. The problem is that it's only one color, which kind of defeats the whole purpose of the color control. Next, we tried using heating. Here you see a little demo. The problem with this is that it's extremely expensive, especially once you try to get beyond 2 or 3 colors. And then finally, we settled on RGB LEDs. I'm sure most of us will be familiar with them. We'll talk more about that later. And of course,
So what did we come up with as our solution? We came up with we came up with this. So this is a RGB fitted fishing lure that you can control the color with via Bluetooth over your phone. And we're also going to produce a companion app through which you can do this. So why RGB? RGB stands for red, green, and blue lights. The combination of those colors can produce over 60 million potential colors and hues. And in addition, the RGB, they require little power, so you're able to connect via Bluetooth easily. And they're programmable in such a way that you can control each individual light, and this allows you to create patterns such as pulsing, blinking, rippling, and so on and so forth.
So here you see some potential different lures. Each of these little sections have their own LED that you can control from our app. On the next slide, you see each row has the same pattern, but different colors, and this could be a potential solution.
So if, for example, a fish species likes the green color, we're able to change it from this to this, like on the fly, and hopefully catch that fish. And so the companion that I mentioned earlier is going to look something like that, maybe. We haven't finished ideating properly. And so the front end is going to be with React Native and JSX. The back end is going to be Node MySQL. So as you can see, the user will be able to select the color from that color wheel and then choose a subsection of the lure and change that color of that subsection. And so
So this is like a digital rendering of what we hope it will look like after it's been complete. So yeah, thank you. So we are Team Rapala, and we are literally lighting the future into the fishing industry. So questions?
When will you be testing this in the East River?
Hopefully a long time away. Also, the fish there are like different.
They all weigh alone.
Yeah.
So for water fishing, should it go by like it's kind of a lamp which you put down in the water.
Kind of, except the light will be there'll be a medium we use to help filter the lights, but it won't just be that one shiny bright light. We'll have like materials that will cover and make it like distribute the light evenly across the water, but it doesn't look awkward to the fish. Yeah, the team in Poland is working on different materials to diffuse the light right now.
How big is the Tanzan?
So Rapala makes a lot of different lures of a ton of different shapes and sizes. We're working with just one of them right now. It's being big. We can't say exactly which one we're beginning to test and but hopefully you'll see one day.
How are you going to make the color transition? Because like LEDs, they go pretty small, individually accessible LEDs are like CO4, CO2. So how do you do so many LEDs in so small space? That will each individually float.
We're working on that right now. Again, we're still in the prototype phase. Yeah. It's something to think about for sure. Yes, Nick?
Have you thought about the price point of lure? Like how much more expensive is it going to be compared to the usual lures?
This is catering towards more experienced fishermen who want to buy something. So it'll be a little more expensive, of course, than your standard lure, but we are trying to keep the price point not too. And we were given the range to have between, let's say, $10 to $25. So, any other questions?
Excited? So next up we have Ocean.
We're gonna some of our guests are very hungry, so we're actually going to take a quick break before we introduce CBI A3, which I really hope you please stay for. That is our Pleasantville team. PDPMP IP is our New York City courses, though we do have Pleasantville students. Lena, wherever she is, comes down. Thank you. Comes down from Pleasantville for it. So food is over here. We're going to ask our guidance counselor guests and our outside guests to please help themselves first, and then our Seidenberg family next. And we'll take about 10 or so minutes. You can grab it if you want to bring it back here, and then we'll head on to CBI A3.
No, it's all good.
The catch box is not.
Yeah, if Katie can listen to it.
Oh, you don't?
If someone can listen on live stream.
I know because the first two teams didn't use
Hello.
That's dope. Easy after. Was it? Yeah, we have what? That I was going to turn to there. Yes. Yes. Real excited. It's casual. I'm not even done. I'm saying like.
So, we're actually starting.
So this is just like your picture of you.
Kind of. So basically, past the month of like, share data, like, ideas. So we have the idea. I wish
You got another presentation?
Yeah, I have a report made. I got the final.
So it's strong, bro.
I mean, not the like the fastest one usually. I'm like, I'm in the back, so I scram. But after this scram, I'm the first one that goes outside and cheats. Like, no, they play both. No.
I doesn't play it. I doesn't play it. How can you play last night when you had this in the morning?
I think the camera is so.
I was like, yeah, so we're gonna do it like that. I was like, yo, I got mad time I'm gonna sleep. I woke back 11, 10, I was like, I got I ran.
I'll be on the side with the seats all
Bro, you gotta love it. You gotta love it. It was me on the train.
Yo, I swear, I was just like, oh, here's my phone, here's my I'm sitting there.
That's dope, man. You did it.
Alright, that's a bit better.
You said it was what?
Yeah, but it's like everyone's like talking super loud and they're all listening to it. So I just said we're turning sound off until the breaks.
Got it. Okay.
I mean, maybe it's still playing, but
Yeah, they can barely hear it. Tofu, are you presenting? Yeah, I'm gonna cry. You should. You deserve to get up there, Tofu. Your goals, Topher. Look, even the way that you drink water is like, oh my god, like.
there's a little wave for the camera. Thank you for doing this.
Anytime. I just felt bad because they said like, sound is working, they just can't hear it from like afar, and this is not working.
So actually, I guess the sound is still on. So.
Yeah. Mute microphone.
Hello everyone. So after the break we have CBI A3 team from Pleasantville and the team name is Ocean 5.
Hey, we're sharing.
Should we clip it on? Here, well here, Kyle, you're gonna go in front of me.
The fifth member of the team, Sven, could not be here because he had a swim meet. Very
Hello?
Just put it on your shirt.
Oh, okay. I'll just hold it right there. Yeah. So, hi everyone. As a professor, this is new to me. All right. There you go. All right. So, as Professor Corderano said in the beginning in our introduction, we were able to go to CERN in the fall semester, and we were focusing on the UN Sustainable Development Goals, our SDGs. Specifically, we focused on goal number 6 and goal number 14, which is clean water and sanitation and life below water. So our whole project revolved around those ideas and how we can help make water, we could help create, fix water problems in our country. So first, my name is Nathaniel Linton. I'm a history major, a senior, and I'm in the Honors College at the Pleasantville campus.
Hi everybody, I'm Mackenzie. I'm an honors computer science major and I also go to the Pleasantville campus.
I'm Kyle Hansen. I'm a information systems major. I'm in the Honors College on the Pleasantville campus.
I'm Will Bender and I'm a computer science major. I'm a senior here.
And as you said before, Sven was unable to make it due to being in the swim meet. And our partners, real quick, we got to practice with students in Mannheim, University of Mannheim, University of Melbourne, and in Porto, Portugal. So students from all over the world. So for CERN, it was basically a 2-week intensive project. And during our time, we focused on concepts of ideation and innovation. We had the opportunity to develop many prototypes incorporating CERN technologies. Our prototypes, once again, focused around the SDG goals number 6 and number 14 specifically, which once again are water and sanitation and life below water. The process was very interesting because we were encouraged to think of future scenarios in which our prototypes would be implemented, specifically the years 2025 and 2030. So really throughout our time at CERN, we were really pushing our mind to really think about how the world may be at that time and how our technology may be implemented. The basis of our project was truly interdisciplinary in nature because it incorporated various students with different backgrounds. I myself being a history major, I thought it was a very interesting opportunity to be at CERN to work with mechanical engineers and physicists because I really had no idea whatsoever as soon as I stepped in there. But I think it's the value of being able to really share our knowledge with one another. CERN is very big on the transfer of knowledge, and that's something I took away. And also, we had the help of CERNies, as Professor Corderano said, and our coach is actually a mechanical engineer. So I was very thankful to be part, and these are some friends that we made, and it was just an awesome experience. Uh-oh. It's a clip. So sorry.
So our project began with conducting research. Basically, we were looking for problems in our local area regarding these clean water issues. So we came up with 20 or so issues in the New York State area that have to do with water. In addition to that, we researched the technologies at CERN before we went so we could connect those technologies with potential applications to solve these problems. So the challenge that we focused on is called combined sewage overflow. So here in New York City, we have a sewage system where basically surface runoff and sewage water are in the same pipes. However, when it rains, there's too much water in the pipes, there's too much liquid. So because it is untreated, they dump it out into the river because there's not enough room in the pipes, and they aren't able to treat it before they do that. So that means that there's feces and sewage and trash from the streets out in the Hudson River, which is the river right outside New York City. So this is obviously a very big issue because human exposure or marine life exposure to human feces can cause infectious diseases, and it's also just polluting the water in our area. And this is a picture.
As you can see, none of us are truly artists, so yeah. So what we were focusing on is trying to get some of the waste out of the water before it even reaches the pipes, to try to move the process of waste management further up the chain instead of down at one central collection point. So what we were thinking was a whole house waste management, in where you would have the water coming in, and you would basically use low pressure dehydration, where water boils at a lower temperature, or when it is in a low pressure vacuum. And so we would use that, dehydrating it and dumping and somehow collecting it. And then we're really focusing on 10 years from now. So we had to imagine what the future is going to be like from there. And what we were seeing is a total shift in how solid waste management in the cities would work, due to like increasing populations in the cities and the need for cities to evolve in how their transportation systems are working. So we would think it would be integrating into the system that the cities would have in the future, and a more efficient way of getting stuff moved out and managed.
Yeah, so we're also, our approach was kind of like the Internet of Things, where it's moving from something that's central. Oh, right. It's moving from something that's central to a more distributed approach, so that it doesn't get overwhelmed and leave combined sewage into the Hudson River. So we looked at a couple CERN technologies, and along with Alex, our coach's guidance, we looked at the turbomolecular pump, which is used to evacuate the chamber and lower the pressure in the chamber. And it's similar to a one-way valve where gases can come out, but they can't come back in, which is particularly useful when you want to really create a vacuum in the chamber. Our second one, which was really interesting, were non-evaporable getters, which are metals and different materials that almost coat the inside of the chamber, and they passively absorb and release gas molecules passively based on heat. And right now we're at the halfway point, so we're still working and ideating and developing more conceptual ideas, but we're also implementing strategies to realize those solutions. And we will be done in April. Yeah. Are we done? Yeah. Yeah.
We're Ocean's 5.
Yeah. Questions?
Particularly probably about CERN, probably the workshops.
Yeah.
It's clear that you've been working together really, really closely. How's it going with the other members of the team? You're still in touch with the people at Swinburne from Australia and the other schools?
Yeah, we have a whole WhatsApp group. And
we also have to do regular blog posts every week. So we're all maintaining of how each other is doing and where in the process they are. So everybody is still connected in that way.
And also we have to keep in touch with our coach regularly. Alex, the mechanical engineer, and we're gonna have hopefully a monthly video chat with him, just to catch him up on what we're doing and how he can help us too.
And you guys didn't have to sign an NDA?
Yeah, CERN's all open. They developed the World Wide Web.
Yeah, so everything at CERN is completely open and free for people to view. So they're really about spreading the knowledge. So there's nothing that's really closed off, and nothing that's guarded with top secret clearance. So.
The first week we were actually there, a representative came and actually was a Transfer of Knowledge host, and she spoke to us genuinely about how she's willing and how CERN is willing to really share their knowledge with the outside world. Particularly, they created the World Wide Web and also the touchscreen, which was created in 1972. Yeah. The touchscreen was implemented in 1972 specifically for the Large Hadron Collider, and I was going crazy because history that's amazing. I really didn't know it was back then, and yeah, but they're so open, as Kyle was saying, and they're really willing to share, and it was just a really cool experience.
Yeah, I thought what was really interesting about this was that we weren't building onto something. We had to project into the future. And what they kind of taught us in the 2 weeks was to really just jump and leap and think about things that you couldn't really do. Like, that's why we have Alex, the mechanical engineer, because he's kind of there for feasibility. Because our early design was splitting things using splitting atoms to produce hydrogen using carbon. But see, that's where Alex comes in. And but it was a really unique and cool experience. Yeah.
Yeah, we really had to. We had like 4-hour sessions of just ideation and innovation where we all sat at a table. And to be honest, we got really close as a group. Sometimes we were snapping at each other.
Yeah.
We were tired, and we still had to create ideas, and then the next day we had to create more ideas, and like we felt like we were out of ideas. We didn't know what to do anymore. But they really pushed us to I guess beyond a barrier. We moved beyond barriers, I would say, mentally, and it was really, once again, really great.
Yeah. So yeah, we plan to be done by the end of April, so if you can join us for our presentation, that'd be great. Yeah, I think it'll be interesting.
Thank you.
Thank you.
Thank you, Ocean 5, for the wonderful presentation and the product. Next up, we have Pexray Tech.
No, please.
Hello everyone, good afternoon. I'm Milind.
I'm Shivani.
And I'm Lena.
And we are Team T-Ray, shorthand for Transportable X-ray System. Our sponsor is Pexray Tech, which is a high-tech Finnish startup, and its aim is to build portable and easy to use X-ray machines. So Team T-Ray is a team of 8 members, 5 based in Finland, in Aalto University, Helsinki, and 3 based here at Pace University. So whenever we think about going to a concert, it's associated with having a good time and to forget all our daily problems. But unfortunately, that is not the case in some events. Within the past few years, there has been an uprising in deaths and injuries that have occurred during such events, like the one in Orlando, the country concert in Las Vegas, and the Ariana Grande concert in Manchester. So our aim here is to avoid such tragedies by using the technology of X-ray systems. So let's consider 2 venues. First, the airport. At the airport, there's a constant flow of passengers and baggages. Therefore, the airports can take advantage of a stationary X-ray system, and also they have n number of trained people to operate on such machines. But it's not the case with venues. As concerts and venues can have different locations, and so there's a need to have a portable X-ray system which can be used at different venues separately. And we have a solution for that. But before we get to the solution, let's talk about how we got to the solution. I'm sure everyone has seen an important warehouse tool which is so convenient and easy to use, but still it plays an important role in the warehouse. I'm talking about the hand truck. I'm sorry. Before we get to the hand truck, our team in Finland assisted in delivering an X-ray system. As we all can see, even though this is a portable X-ray system, it still requires 3 people to handle it, and the machine is quite heavy, and there are problems like the doorway, small doorway, and there can be door jams. So it becomes difficult. Like you can see, my team members are struggling to get this simple portable X-ray machine in through that door. And also, we spoke with a lot of industry experts, X-ray industry experts, and we got to a conclusion that to handle one single X-ray machine, we need 3 people. One is to check the flow of the bags. The second person is examining the bags on the screen. And the third person is present for more thorough inspection of the bags. In our secondary research, we also found out that the softwares that are being used by these X-ray machines are quite complicated. And a normal, to use these software, we need a trained personnel, we need to train the person. And in situations of panic, it becomes quite difficult to play around with the software. So after a thorough discussion with the team members, we shortlisted 5 major requirements that have to be present in our X-ray system. One is that it can be moved by easily moved by one single person. We want to reduce the number of people that are working on site with the machine, easily maneuverable, an improved user experience, and an easy to use software. Now let's talk about the X-ray machine concept. Now take the example of a hand truck. Even though a hand truck is a simple tool, even the weakest person can easily move around heavy weight using it. So the main advantage of the hand truck is that it uses the balance point around the center of gravity, which helps it to easily move the heaviest objects in and around the warehouse. So with this inspiration, we tried to build a X-ray machine. So as the X-ray machine is quite huge, it is not possible to use it as a hand truck. So what we did was, we divided the machine into 2 parts, 2 separate pieces, and each one can be moved by a single person separately. So the physical mock-up is not present here, it's at the Aalto University, and my team has given a demo, and we'll just see how the physical mock-up is. So my team member Sam is going to place a wooden plank which will act as a doorway. And also the wheels for the portable X-ray machines are quite small. So we have tried to increase the wheel size so that it becomes easy. As we all know, for the hand truck, the wheels are quite big. So we tried to increase the size of the wheel. As you can see, this single piece weighs around 200 kilos, but it is easily been transported by my team member Elias without any hassle. So as we said, we divided the machine into 2 parts. So this is the first part. As you can see, the door jam is not at all a problem. And once the machine are placed next to each other, it can be easily clipped together, and this becomes one whole working X-ray machine. So our aim here is to build a machine that is easily maneuvered by one person, can be operated with less people present, and won't get stuck on door jams. Now let's talk about the user interface concept.
So as explained by Milind earlier, we have seen an airport venue where we require 3 people in total to handle and have a good user experience overall for the X-ray machine. The problem in that is we are having more manpower because 3 people are involved to just handle one X-ray machine. Other thing was the operator present there who is actually checking the images is not directly involved with the bags or with the X-ray machine. He has to just check the images, but there are always interruptions because he has to tell the bag checker that oh, this bag has an issue, so please check it. So there is a lot of interruption, and for the passengers also there is a lot of waiting due to these issues. So yeah, this is the airport venue where 3 people are present, namely the traffic director, the operator, and the bag checker. So we had a simple solution after a great discussion that this can be reduced considerably, that we can move the operator in a remote position. So there will be only 2 people present near the X-ray machine. One would be the traffic director or the welcome guy, and other would be the bag checker. Also the operator would be present in remote location so that he can focus only on the images and not on any other thing or any other person. Also to bridge the gap between those 2 person and the operator, we are having a discussion on how he can communicate with the bag checker so that the bag checker knows that the bag has a problem or not. So for communication, we might be having an audio communication, or we are also having a research on augmented reality. So he can use a device like glasses, and he can have the details or the notes of the bag directly on his glasses. So that is one of our research going on. I will show you a short demo on the UI design which we are having up till now. So it's an improved UI design because as you see, as you all have seen, that the existing softwares are really outdated, a bit outdated, and have lots of functions which needs a lot of training. So I'm going to show you a short demo. So the operator will be using an iPad as a remote control, and also he would be having 2 screens to view the images very clearly. This would be our landing page, and as you can see, he has all image enhancement points on right hand side. He has an option to write notes on the bags, and that can be redirected to the bag checker. Also he has the handling capability of playing, stopping, sharing, printing the images if required. Also he can browse the previous images he has seen or check the notes on that. As you can see, there are also bag IDs related to each image so that he can tell the bag checker that which bag to be checked or not checked. So this is a basic prototype we are working on currently, but there are lots of improvements and enhancements going on, lots of discussions going on. So these are our next steps, that we would be finalizing our UI design. We will be building an actual X-ray working machine so that it can process the X-ray images towards our software. Also we are yet to decide our technical stack for the development of our software, so that's also one of our stack. This is our current solution. It's in a lot of iterations currently, and lots of discussions are going on. But we are hoping that our solution will provide a good product to the company for which we are researching this stuff, and also a great experience for the passengers on the venues, event venues. Thank you. Questions?
Any questions?
If you have 2 parts of the machine, how do you keep the radiation?
From the radiation coming out. So whenever you turn on the machine, that's when the sensors start, right? So you just have to plug them first. There's a whole box inside, and we have materials to avoid the radiations from going like outside. So
Between the 2 machines, there would always be a gap. You can't make that airtight.
no, we can. So we have material which will completely block any kind of radiation from going out. So the main aim was to make it portable, and so this, like, the machine is portable. It can be easily used by a single person, and getting the radiation outside, it can be easily avoided. That is not a problem. Yeah.
Yeah, I don't think the radiation would be a big issue.
Yeah.
Yeah.
It'll collapse internally.
Yes. So you still have 3 people though operating the machines, am I correct? Or operator has an ability to see the screens on several machines? What would be? Because you were trying to reduce the number of people serving the machine.
Yep.
So with 3, you moved one a little bit farther away, but does that mean that you still have 3 people? Or that operator will have several machines and the screen, several screens?
Yes, so we have not yet decided for multiple X-ray machines that like how it would have use, but the operator, yes, he would have the screens. If we consider a single X-ray machine, he would have 2 screens, and the tablet, the prototype which I have shown, that would be in his hand, so that he can operate that, and he will have a audio communication with the back checker outside. So we have So we have 3 people still engaged, but there will be reduced delays because the operator can merely only focus on the images. So that would improve the scanning, and also he can communicate with the back checker, so that won't be any issues. So it will be overall a good user experience.
So, I mean, it is true that we still have 3 people, but as I said, during the airport, they have assigned like particular people just to focus on that thing. But for the venues, it is always good to have less people for the security. I mean, if we have more people for the venue, then it becomes intimidating for the people who are entering the venue, right? So if there are less people, people will not be intimidated, and they won't. Sometimes even we feel scared when there's a lot of security check going on, even if we don't have anything. So that was our main aim, that the operator is at the remote location. It's just the 2 people who are working with the X-ray machine, and there's a constant audio and video communication between the operator and the back checker. So yeah, because I mean that was our main aim, to make it more user friendly, and the people shouldn't be intimidated by just looking at the X-ray machine or the people who are working with it. And if we have multiple X-ray machines, then we can have 1 or 2 operators with multiple screens, and they can just from a remote location easily check the bags, like yeah.
Yes. In regards to your process, what has been the biggest challenge so far, and why?
During the research, we had a great challenge because this is related to security. So when we were going to any security agencies or the people who all actually have the existing X-ray machines, who are actually using them on the venues, they were obviously not permitted to share any details of the X-ray machines with us. So due to that, we really had a lot of issues, like how the designs are and how the operator is actually using that softwares, or how they are moving the machines and stuff. So yeah, that was our biggest hurdle.
And I'm very impressed with the product description, but you've got a very distributed team. Are you the only person in Pleasantville later?
Mm-hmm. Yeah.
So you're in Pleasantville, you're in New York, and the rest of the team is in Helsinki.
Yes.
How is that working?
So we have a Slack channel, and we make sure that we have a weekly meeting with the team manager, and we have set up deadlines. I mean, sometimes it becomes difficult to to show up for the meeting because because of the time difference and stuff. But still, like, so far the things have been good, and there's a good communication going on between both the teams. So yeah.
What's your name?
Lena.
Awesome. So for the software I saw that you created, did you actually make it up yet, or is it a prototype, or what's your system with that?
So right now it's only a demo, so we only wanted to get what it would look like to kind of get what users, how would they would interpret it. So it's not fully working, it's not connected with the machine just yet, but we just wanted to see what it would be like.
So would the person that's viewing it and the person that's outside would have both an iPad?
So the person, the user interface would only be for the operator, which would be remote. And from there, the operator would be able to tell the people on site, so the two people, so we did try to reduce the personnel on site, so they will not be able to have access to that. It's only the operator off site.
Thank you.
As a person, like, he has direct contact with the bag, right? So even if there's something suspicious, he just has to tell the bag checker and he'll just check the bag. So yeah.
You had mentioned that on your interface there was this capability to give the bags IDs. How does that work with the two people who don't have the system, since they would only would be the only person who has the system know the ID number, or how would that be transmitted?
When a bag is going into the X-ray machine, it would be tagged with a number, and that number would be related to the actual X-ray image of the bag, and that details, like if you would have seen, the operator have a notes or details component there, so that he can type his notes that if the bag is okay, or if the bag, you should check the bag or not. And that would be connected to a device which the bag checker would have. The communication device would be an audio device, or it can be an augmented reality, like I suggested, glasses, so that the image of the X-ray machine with the notes would be displayed on the glasses, and that would be the bridge. The bag ID would be the bridge between that.
So they would know, the bag checker would know the ID as well somehow.
Yeah. Yeah.
Yeah, actually he don't need to know the bag ID really, because the X-ray machine and the notes detail will be directly flashed on his screen.
All right. Thank you.
All right, thank you.
So much.
Before last team, I'd like to introduce Patrick from Institute of Innovation and Industrial Management in Austria. And lastly, we have Team Voestalpine.
I'll get it. Okay, so good afternoon, ladies and gentlemen. We are Team Docutize, and we're going to present the solution we've been working with. So this is our team.
Hi, my name is Grigor. I study production science and management at TU Graz, and I'm the project manager of this team.
Hello, I'm Topher. I study here at Pace University. I'm studying information systems, and I'm the project manager for the New York City campus.
Hi, my name is Oliver. I am studying at TU Graz too, computer engineering, and I'm also project manager. We have quite a few.
Yeah. And he will be joining in this presentation. So I'm Ian. I'm a master computer science student here at Pace. I'm the researcher for the team.
Hi, my name is Vivian. I'm an honors computer science student here at Pace University, and I am the time manager and the archivist for this team.
Hello, my name is Laura. I'm studying at the TU Graz Business Economics, and I'm the business shark of the team.
Hello, I'm Bernd. I'm a grad student and I study technical physics at TU Graz, and I'm the maker of this.
So, as you all know, this project is part of the Product Innovation Project, which is a partnership between TU Graz and Pace University that aims to team up students and give them real industry problems to solve.
In our case, the company that gave us our task is called Voestalpine Böhler Aerospace. They're a steel producing company based in Austria, and they're in the aerospace industry. The challenge of our task is the company is producing the steel parts and they are testing it themselves. And right now they are using the non-destructive testing method where they apply a paint on the part, and this helps them that the cracks that are on the parts can be visible to the human eye. And a trained inspector is then looking at the parts manually and also documenting everything manually on a sheet of paper. That's the process right now. And our task is to digitalize this documentation and to automate it. And for that, we also analyze existing solutions on the market, understand the method, design a product concept, and build the prototype. The goals of our task are that we have the minimum requirement to find a way to capture 100% of the surface of each part. And the second goal is to reduce the worker involvement so that we can reduce the risk of human error. And another goal is to reduce the process disruption. So our solution should be adapted, should be introduced easily into their existing process. And as a bonus goal, it would be great for the company if our solution could also analyze the pictures and locate the cracks and learn some patterns from that so that they can improve the whole chain of processes in the company.
So, because our only customer is the company, this is not an outside solution, it's an inside solution. We could focus more on the technical aspects of the research. But what we find out is that companies don't usually make this information available publicly. Because of strategy and confidentiality, it's really hard to get access to this kind of information. So what we did, we went to other industries that have similar problem, like the medical imaging industry or other computer vision in industry. And we tried to apply their solutions to our problems. Also, we went to talk to a few experts, especially in the computer vision area, because it's one of the most difficult to tackle in our task. And we tried building a lot of prototypes and see how they perform, where they fall short, and how can we improve on that. And based on that, we got a few concepts. We were able to scan 100% of the surface of the part, integrate with computer vision and artificial intelligence to make sure we detect the cracks, identify the part, and the position of the cracks in the part. So we cannot go a lot into our solution because of NDA agreement, but we use those 5 categories to think our solution. So how can you leverage software to make it more powerful? How can the parts be handled? Because there are different shapes, different sizes. How do we account for all of that? Having the images, how can we detect the crack? How can we set exactly what's the position? Because if there's a crack in the part, it has to go to a process to fix it, and then goes back to the line. Taking pictures, so how do we automate this whole process? Or will it be totally automated, or will it be integrated with some of the workers? How do we identify the part? How to make sure that each part is recognizable and uniquely identified?
The next steps of our project are to first, in March, meet the company for a 3rd time so that we can discuss our ideas and concepts that we developed here in New York, and hopefully also decide together with them which idea we should further develop. And then in April, we will go more into depth on that idea and reiterate. And also we have to build a prototype until May for the final presentation at the Innovation Festival in Graz in June. With that, we are already at the end of our presentation. Thank you for your attention.
And now I'd like to invite the whole team to answer questions for the roasting. The roasting.
Oh, the roasting.
So, Grigor.
Yeah.
From your engineering perspective, what are the remaining challenges to deliver the product to the client?
Well, the main challenge would be, I think, the handling of the parts. We're working on that, making some concepts, but generally that is the main thing. And then the second thing is the software, like the image processing, which we'll use, but that's not my expertise. That is more.
So yeah, the software people think the hard part is programming everything. The mechanical people think the most difficult part is building everything. So it's expected. There's a few more. Yeah.
Yeah, do you take photos of the objects and then stitch it together to build up maybe like a 3D model?
Somehow, yeah. In some sorts, yes.
Yeah.
Is the software automatically adjusts to kind of, build an accurate model, or do you guys have to manually?
That's too much detail.
Yeah.
Cannot go into that.
We can't tell you that. We might have to kill you.
but those are options. We've been through those. We think actually both like stitching to the model and then other solutions.
Do you need like a sensor that has a lot of megapixels, or is there like a minimum?
No, actually, image quality, as long as it's able to recognize, we don't need like a huge detail in it. Someone else?
Yeah, Vivian, how would you describe the working dynamic with the team? You spent a lot of time together.
Yes. We initially had some communication issues, but I feel like we've since worked everything out, and we have a really strong team bond, I'd like to say, because we spent a lot of time together, especially in honors, just huddled together in a room, ideating and coming up with prototype ideas. You can ask Jackie, she's taken so many videos of us together just huddled in a corner, drinking coffee and
Drinking
Well,
coffee.
and ideating,
That
of course.
bonds, drinking coffee and.
I thought you were going someplace else. I'm reassured.
Was the room locked?
Okay, so I guess that's it. Thank you for attention.
So John Wynn, entrepreneur in residence. Other than the NDA, do you have any sharings on what you've seen today?
Hi everyone, my name is John. I am super active in the New York City tech community and have been working with PACE here to help bring some of those opportunities closer to students. So work with a lot of entrepreneurs inside of New York City, work with the investment community here, and so seen a number of different technologies developing in pretty innovative circumstances. And with all that context, I'm super impressed by everything I saw today. You guys have an incredible opportunity, not just working with engineering talent on cool technologies, but doing it with real companies. That's a tremendous opportunity to really get contact with building your own technologies one day, but also building career opportunities and getting actual experiences that speak so much more loudly to your potential, to a potential employer, than almost anything else. So first of all, congratulations on that. The second thing that I was sort of looking to hear about from each team was, how are you developing the conversation with whoever the user or the customer is, right? There's a lot of emphasis, it seems, on coming up with great ideas, as many as you can, ideating all the time. It's an incredibly important part of being an awesome innovator and entrepreneur. But bringing those thoughts into conversation with your potential customers or users is just as important. So I saw on a couple of the roadmaps here, that people were thinking about. How do we evaluate this idea before, how do we talk about it to the customer? I think a lot of times those things are better done at the same time. But other than that, I mean, again, congratulations to everyone on the amazing progress. I can't wait to be back in April to see the results. So thank you guys for the time today.
Thank you, John. Incredibly impressive. Such bright people can be such nice people. And to our friends from Graz, thank you for coming all the way here, and thank you for making us better. You really, really
Thank you.
It's our pleasure. And to our faculty sponsors and graduate students and our teaching faculty, such impressive work. And I came here to PACE 15 years ago because I met people like you all. And the fact that we have this opportunity to have brilliant, brilliant people from Egypt and Austria and Brazil and Pleasantville and this is just a wonderful, wonderful thing. We even have somebody from Canada. So continue to enjoy the process. Let us know how we can help you. For those of you who are here observing, it's really cool, but these folks work incredibly hard. It's a very intense experience, and I know it puts you through some changes. So thank you for being open to that. Thank you for sharing. And I will turn it back over to Dr. Capel and Andrea.
Again, just to echo what Dean Hill said, thank you all for coming, and we want to thank our industry partners. We wouldn't be able to do this without their support and guidance, and of course their financial support, and we're really excited. We hope you all join us in May. The teams are going to be presenting at the Undergraduate Research Day, so they will be joining everybody, so we hope you see their somewhat final product. Each team's in a slightly different place.
And I would also like to recognize some people that were instrumental in the success of those projects. I would like to start with our coach from Austria. Would you like to say a few words, please?
Yeah, so again, thank you for having us here. For us, it's an incredible chance to work together with international students here from PACE University, and also, of course, in Austria. So we have international students at home, and we have them here, and it's like, yeah, every time we see that the results are amazing. We see kind of the struggling in the beginning with communications, but as soon as the teams figure that one out, it works quite well. And yeah, we love it. We want to keep it that way, and we would be glad to keep it that way. So thank you for the opportunity.
And not everybody could make it to the halfway show today. I would especially like to recognize my colleague, Dr. Richard Klein, who partnered with me in the coaching of the challenge-based innovation team. I would also like to recognize the faculty, department chairs across the university. You have supported the students with, letting them submit some work late, being very accommodating with their swim schedules or all sorts of honors obligations, and we could not have pulled this off without the support of colleagues in the university, from study abroad to the honors college to faculty members, department chairs. Thank you for being such great supporters. And last but not least, the students. You have been through a lot in such a short amount of time. It's been just amazing to observe you grow and adapt and deliver such amazing projects that we're only halfway through, so cannot wait for the finals. But you've been impressive, you continue to deliver great work, and thank you for making this enjoyable for us as well. Thank you everyone for coming, and we look forward to having you around for the next events. better.